Hi everyone, welcome to my channel Maths Insights. In this video, I am going to explain how to find zeros of a quadratic polynomial by using graph. In the previous video, you learned how to draw the graph of a linear polynomial and how to find the zeros of the linear polynomial. In this, we are going to discuss the zeros and graph of quadratic polynomial. Shall we? Before going into the topic, you have to learn what is meant by a quadratic polynomial or quadratic equation. You know, a polynomial whose degree is 2 is called a quadratic polynomial, and you have to learn what is the general form of quadratic equation or polynomial and what are the types. We will discuss them in detail. The first one is purely quadratic equation. What it is mean purely quadratic equation? See, actually, if you want to write any quadratic equation, you will write like this: ax square plus bx plus c. In this quadratic equation, this a comma b comma c are belonging to set of real numbers. That's why it is called real quadratic equation. And here the main important point is a value should not be equals to 0. If a value will become 0, then this is not a quadratic polynomial, that will become a linear polynomial. That means if this will become 0, you will have only bx plus c. That is nothing but first degree polynomial, and it is called linear polynomial. So what is purely quadratic equation? It's very simple. If you miss the term which is containing first degree, that means if bx is not containing in this quadratic polynomial, that is said to be purely quadratic equation. So you may write ax square plus c. This is a purely quadratic equation. Why? Because you are missing the term which is containing first degree of the unknown quantity. And coming to the second one, unaffected or complete quadratic equation. In this case, you have to write ax square plus bx plus c. In this quadratic polynomial, these two terms should not become 0. That means second degree term and first degree term should not become 0. Then that is said to be a unaffected or complete quadratic equation. Suppose if it will become 0, then this will become ax square plus bx. You have to have x square term definitely, otherwise it is not a quadratic equation or polynomial. Finally, the standard form of a quadratic equation. Everybody knows the standard form of this quadratic equation is ax square plus bx plus c is equals to 0. This a, b, c are real numbers and a should not be equals to 0. Then question arises and the students may confuse what is the difference between these purely quadratic unaffected and standard form of a quadratic equation. Here in the unaffected or complete quadratic equation, definitely the constant will become 0 and this a comma b should not be equals to 0. But in the standard form, b may be 0 but a should not be 0. So that is the main difference between complete quadratic equation or standard form of a quadratic equation. In the standard form, except ax square, all may become 0. That is a standard form of quadratic equation. You may put, suppose 2x square is equals to 0. This is also a quadratic equation. Why? Because you may write 2x square plus 0 into x plus 0 into 3 or 4 or whatever the number may be. So you can write in this form, but it will become a quadratic equation, but it will not become complete quadratic equation. Why? Because this is becoming 0 and that will become purely quadratic equation. Why? Because in that you are missing the second term. That's why that is called a purely quadratic equation also. So both of these two will become standard form of quadratic equations. We will now discuss how to draw the graph of quadratic equation, and by using that graph how to find zeros of the quadratic polynomial in detail. I will take a quadratic equation and I will draw a graph for that, and we will learn how to find zeros of that quadratic polynomial. Let's I am taking x square plus x square minus x minus 6. This is a quadratic equation, you know very well. So you have to find zeros. What are zeros? You know very well. Some values of x, if you substitute in this quadratic polynomial, its value will become 0. So those are called zeros of the polynomial. Now I will draw the graph for this quadratic equation. You know how to draw a graph for a linear polynomial in the previous video, and the graph of a linear polynomial is a straight line. To draw the straight line, any 2 points are enough for that. But here the graph of quadratic polynomial is not a straight line, it's a curve. So to draw curve, you have to have at least 7 points on that graph. By taking those 7 points, we will draw the graph of that quadratic polynomial, and we will decide where it is meeting the x-axis. Why? Because 7 points, so it may extend on either side of x-axis or y-axis. So you have to show two equal parts on either side of the x-axis or y-axis, then we will find the zeros. I will explain it roughly, then we will take one problem, in that it will clear to you. See, this is the x-axis and y-axis. First we have to prepare ordered pairs for the points to plot on the graph. So we have to prepare 7 ordered pairs for the points like this. See, whatever the numbers you may assume for that. So if you are drawing a graph for any equation, you have to assume it as y is equals to x square minus x minus 6. I am assuming some value for x, then I will get another value for y. So after finding x and y values, you have to write the ordered pair. So x value, y value, x comma y value as ordered pair. You have to prepare like that. So after preparing these points, you have to draw the points. Suppose, see, this is the first point, this is the second point, this is the third one, suppose, and this is the fourth one, this is the fifth one. Now you have to draw this graph by using scale. So you have to join these 2 points by using scale only. You should not use scale here. That means to join these 3 points you should not use the scale. So for these 2 points only you have to use scale. Then again you may use scale here, and also scale here, and also scale here. After drawing like this, you have to find, you have to observe where it is meeting the x-axis. On x-axis the y coordinates are 0. Suppose if it is meeting at minus 3 comma 0, and here it is meeting 2 comma 0, then minus 3 comma 0 and 2 comma 0 are the 2 points where this graph is meeting x-axis. Why we are taking the meeting points of x-axis means there the y value will become 0. Why? Because we have to make this y 0, that means y coordinate should be 0. Y coordinate is 0 on x-axis only. That's why we are taking the points where the graph is meeting x-axis. Draw the graph of another quadratic equation. It may be like this also. It may be like this also. That means this is in the form of u and this is in the form of inverted u. These two shapes are called parabolas. You will learn in detail about parabolas in your higher classes, and when we will have this type of shape and this type of shape, see, ax square plus bx plus c is equals to 0. This is a quadratic equation. If the value of if a is greater than 0, that means a value is greater than 0, then you will have a shape like this, U shape. And if a less than 0, that means in this case you will have a shape like U, and in this case you will have a shape like inverted U. These two are called parabolas. We will take one problem, then we will clear everything how to find zeros of the polynomial. Now I am taking one example, that is, draw the graph of x square minus x minus 6 and find the zeros. Okay, so as we said, we have to prepare a table to find the ordered pairs for the points. See, you may assume whatever the values for x, but care should be taken. If you take any particular value for x, y value may be more, that means 20, 30, so 40. You should not get that such type of huge numbers. Why? Because our graph paper is very small. You have to increase our scale, then the graph will become very small. You cannot identify the points where it is meeting x-axis. So if you take any values for x, y value should be in our control. That means take care that it may not be more than 10, but it is not wrong, it is also correct, but your graph will become very small. It is not clear. So I am taking 3, 2, 1, 0, minus 1, minus 2, minus 3, and I am finding y values. Suppose if you substitute x is equals to 3 in this, y is equals to x square minus x minus 6. See, 3 square 9 minus 3, 9 minus 3 is 6, 6 minus 6 is 0. Similarly, I am taking minus 2. Suppose I am explaining one point. If x is equals to minus 2, suppose, then what is the value of y? See, minus 2 whole square minus of minus 2 minus 6. That implies to minus 2 whole square is plus 4. So 4 and this minus into minus will become plus, so plus 2 minus 6. That implies to 4 plus 2 is 6, 6 minus 6 is equals to 0. Therefore y value is becoming 0 when you take x is equals to minus 2. Therefore I am writing 0 here, and the ordered pair means you have to write the x coordinate first, then y coordinate next. In this way you have to prepare 7 at least. You may prepare less than 7 also, but you have to find where it is meeting. It has to meet x-axis until you have to take the points. So I am plotting these points on the graph and I will find the zeros. First, if you see 3, 0, so 3 is x coordinate and 0 is y coordinate. Where it is 3. And also scale, I have written the scale. On x-axis 1 centimeter is equals to 1 unit, and on y-axis 1 centimeter is equals to 1 unit. Why? Because my values are not more than 10, and whatever the x and y values I have written here, I have placed on the graph. Now 3, 0, 3 is here, 3x value is 3 and y value is 0, means you have to put a into point here. Why? Because if y coordinate is 0, that point will be on x-axis. So that's why I am taking it on x-axis. And second, 2, minus 4. That means x is 2. So x is 2 and y is minus 4. So minus 4 means we have to come down. See, here you can find y value as 4. So x is 2 and y is 4 means you have to put an into point here. 1, minus 6. X is 1 and y is minus 6. X is 1 and y is minus 6. So you go here. And next one is 0 comma minus 6. X is 0. When x is 0, that point is on y-axis, and minus 6. So that point will be here. And next one is minus 1 comma minus 4. Minus 1 is x. See, minus 1 is here and y value is minus 4. Coming down, you could find here. Okay. And the next one is minus 2 comma 0. Minus 2 is x. Okay. 0 is y. Where it is minus 2, this is minus 2, and y is 0 means that point will be on x-axis. So it will come here. Next, minus 3 comma 6. Minus 3 is x and 6 is y. Where you could find it is, so you may find here the point. After plotting these points, you have to join whether with your hand or by taking a scale. But if you take scale, you have to join these 2 points only by using the scale. Then again you have to change the direction of the scale and you have to join these 2 points. So I am joining this by hand, and also this one and this one and this one, this one and this one. If you go further, you will have another point here only. So if you extend like this, so this is the graph of y is equals to x square minus x minus 6. I am erasing this one. Now our aim is to find the zeros, means we have to find where these parabola is meeting x-axis. If you observe, it is meeting here. This is the first point where it is meeting, that is minus 2, x coordinate minus 2, and since it is on x-axis, its y coordinate is 0, therefore minus 2 comma 0. And the second point is, if you take x is 3 here, the point meeting x-axis at 3 comma 0. So these are the 2 points where it is meeting x-axis. Therefore you have to write from the graph it is observed that the graph of y is equals to x square minus x minus 6 is meeting x-axis at minus 2 comma 0 and 3 comma 0. Therefore x coordinates of the points are zeros of the given polynomial. Okay, polynomial. So after finding the points where it is meeting x-axis, you have to take the x coordinate. See, in the first point the x coordinate is minus 2, in the second point the x coordinate is 3. Therefore minus 2 comma 3 are the two zeros. Okay, you may verify whether you have drawn graph correctly and you got correct answer. So verification, you may write verification. So you have to take, see, already y value is 0, therefore x square minus x minus 6, you have to find its value. It has to become 0 when you take x is equals to minus 2. I am substituting x is equals to minus 2 whole square and minus of minus 2. Already this is minus 6, so minus 2 whole square is nothing but plus 4, minus 2 into minus 2, and this is plus 2 minus 6, that is 6 minus 6 0. Therefore x is equals to minus 2 is 1 0. And verify this also. Here from the graph itself it says that when x is equals to 3, y value is becoming 0. That means the value of this polynomial is becoming 0. Therefore it is verified and found that you have drawn correct graph for the quadratic polynomial. We will take another question and this will become very clear to you. Now I am taking the second question, that is, draw the graph of y is equals to 6 minus x minus x square and find the zeros of the polynomial. If you observe, it is not in the order, so I am setting it in the order. See, x square term has to come first, therefore I am writing minus x square, and this is minus x. Finally plus 6 is the constant. If you write like this, you will get the coefficient of x square minus 1. That means we discussed that when the value of a is less than 0, then you will have a graph which is in the shape of inverted U. We will see and how it will touches the x-axis. Similarly, what you did in the previous case, I assumed some values for x. See, 1, 2, 3, 0, minus 1, minus 2, minus 3. So not only these values, you may assume whatever the values you may like, but don't take bigger values. If you take bigger values, you will get bigger values for y also. Then it will become somewhat difficult to plot the points on the graph paper. Why? Because in the graph paper you have some centimeters only. So if you have bigger values for x and y, your graph will be very shrinking. So that will not be clear. I have taken these values for x and I got these values for y. You have to care should be taken. By assuming x value, you have to calculate correct y value. If you should not calculate correct y value, your graph will go wrong and answer will also be wrong. Okay, so if I take x is 1, I got y 4. Therefore 1 comma 4, 2 comma 0, 3 comma minus 6, 0 comma 6, and so on. I will plot these points. Say 1 comma 4, x is 1. Where it is x? See, x is 1 and y is 4. So you have to go up here. You will have the point here. X is 1 and y is positive 4. And next one is 2 comma 0. X is 2 and y is 0. You know that when y coordinate is 0, that point is on x-axis. Therefore this is the point where it meets. Next 3 comma minus 6. That means x is 3, y is equals to minus 6. X is 3 here, minus 6 means you have to go down. You will find this point here, minus 6. See, this is the minus 6 and this is plus 3. 0 comma 6. Again here x is 0, y is 6, means it will be on y-axis. Where it will be? 0 comma 6. See, you will find here 0 comma 6. And next one is minus 1 comma 6. X is minus 1 and y is 6. So you have the point here. This is minus 1 comma 6. You have here the point. Next one is minus 2 comma 4. Minus 2 is here, 4 is here. So therefore you may draw this like this. And also the last one is minus 3 comma 0. See, y coordinate is becoming 0. Definitely this point is on x-axis. Therefore it will be here. So if you join these points, okay, you will have like this. You have to draw this like this. Okay, in this way. So up to this only have taken points. If you take another point, then your graph will extend like this. If you observe, the graph of this quadratic polynomial is in the shape of inverted U. After drawing the graph, you have to identify the points where this graph is meeting x-axis. If you observe, this is the point where it is meeting. See, the point is on x-axis. Therefore y coordinate is 0. Therefore minus 3 comma 0 is the first point, and if you observe, it is meeting at 2 comma 0. 2 comma 0. Similarly, what you did in the previous one, from the graph it is meeting, it means the quadratic polynomial. meeting x-axis at 2 points, that is minus 3 comma 0 and 2 comma 0, and their x coordinates are minus 3 comma minus 2. You should not put these two within the bracket. Why? Because this is not a point. You have to write them individually. Therefore, zeros of the quadratic polynomial is equals to minus 3 comma 2. You may verify whether these zeros are correct or not. See, verification. We may do verification. Actually, verification is required if you could not find these on this table. See, for x is equals to minus 3, you are getting y 0. That means this value is becoming 0. That means when you substitute x is equals to minus 3, total value is becoming 0. And also, if you see 2, at 2 and also you are getting y value is 0. Therefore, in this way, you may calculate the zeros of the quadratic polynomial. I have explained two problems. You may have different and more problems I will give at the end of this video. By solving two problems, as I said previously, the graph of quadratic polynomial is meeting the x-axis at 2 points. But it is not true in all cases. You have 3 cases. That means the first case is case 1. Case 1, when it meets the x-axis. So it may be like u or inverted u, whatever it may be. So you may have like this also. Okay. In this case, the graph of the quadratic polynomial is meeting the x-axis at 2 distinct points. Distinct or different, both are the same words. You have to take the x coordinates of those 2 points as our zeros. This is the case 1. Intersecting at 2 distinct points. Okay. And in the second case, they may meet, or in other words touch. The graph of a particular polynomial, quadratic polynomial, will touch the x-axis at only one point. See, I will show you the example. So it may be like this, okay, or it may be like this. See, this is the point where the graph of this quadratic polynomial is touching. Suppose you may take it as 2 comma 0, and also suppose in this case 3 comma 0. Then we will have only one x coordinate, that is the 0, but it will repeat twice. Why? Because for every quadratic polynomial you shall have 2 zeros. So when it is touching at only one point, you have to repeat it twice. 2 comma 2 are the 2 zeros. In this case, 3 comma 3 are the 2 zeros. So we have to write the same description as in this case. And final case is, see, touching x-axis at only one point. Roots will repeat. Okay, roots will repeat. That means the point 2 comma 0, x coordinate is 2, 2 comma 2. So case 3, in the case 3, the graph of the quadratic polynomial will not touch x-axis at all. So if you take the example, so you may have like this. See, these are the two graphs, two parabolas. In this case, you observe that this parabola is not at all touching the x-axis. So we have to say that this quadratic polynomial will not have real roots. There are no real roots for the given quadratic polynomial. If it is not touching x-axis, there will be no real roots. You have to say, or no real zeros. So these are the cases where it meets the x-axis. How it will meets the x-axis. Now I will give some problems for your practice. Then you may take those for your practice to clear the concept more. Take these problems. First one is x square minus 6x plus 9, x square minus 16, x square plus 3x minus 4, x square minus 4x plus 5, x square minus 1. After drawing the graphs of all these, we will find that they may be inverted U or in the shape of U. You have to find where they are meeting x-axis and find the zeros. Care should be taken while calculating the y value. I hope this video is helpful to students of 10th class or others also who are not having the knowledge of finding the zeros of the quadratic polynomial. If you like my video, kindly subscribe to it, comment it and share it to whomever it is useful. We will meet in the next video. Until then, have a nice day. Thank you.